Production analysis by modeling of unfinished product generation in rolling mill of steel industry. Abstract: every steel industry produces unfinished products along with finished products. In merchant mill of a steel plant uses hot rolling process to produce merchant products like angles, channels, beams, bars, and TMT bars, etc. In this process billets are heated at 1200 plus or minus 50 C in reheating furnace and passes between rollers of stand. Merchant mill sometimes generates unfinished products, cobbles, which results in failure of the process technology. This problem is responsible for mill trip, which thus stops the rolling for some time. It is observed approximately 2 to 4 cobbles generated per day in rolling hour. We found there is increase in load of stand and decrease in temperature of heated billets. Hence, for minimization of cobbles, radiation pyrometer is installed after rolling stand in existing system. The data such as temperatures of billets and corresponding load of the stand are collected through the adaptive control system through monitor and are analyzed by software IBM SPSS Statistics 20. Result of the analysis consists of mean, standard deviation, correlation, and regression coefficient of load and temperatures. The finding shows that there is a significant negative relationship between load and temperature, i.e. load is inversely proportional to the temperature. Hence, optimum temperature must be required for continuous and uniform rolling process in steel industry. By this modification there is increased productivity, quality parameter of the merchant products and profit of the mill. Keywords: cobble, radiation pyrometer, angles, channels, rolling. Introduction: merchant mill operation is based on hot rolling process, which produces angles, channels, beams, bars, TMT bars. In this study we measure the load and temperature of heated soaked billets before and after passing between the rolling stands. For load measurement, ammeter instrument is installed in the process, and for measurement of temperature of billets uses thermocouple. For the data collection related to generation of unfinished products, instrumentation method is applied. We use radiation pyrometer instrument which measures surface temperature of the heated billets, which is passed between the rollers while rolling. It is a non-contact temperature sensor that infers the temperature of an object by detecting its naturally emitted thermal radiation by the surface of very hot object. An optical system collects the infrared thermal radiation of the heated object and focuses it on detector. The detector converts the heat energy into electrical signal to drive the temperature display. Also, we found the impact of load on rollers by instrument ammeter 8. Merchant mill. The merchant mill is semi-continuous high-capacity mill which is designed to roll 0.5 to 1.0 mt per annum of finished products. The mill consists mainly 3 sections as: reheating furnace, the mill stands and cooling beds, finishing zone and shipping. Raw materials used are billets of size, in mm, 90 x 90, 95 x 95, 100 x 100, 110 x 110, 105 x 105 and length ranging from 5 m to 6 m. Billets are supplied from stockyards by electromagnetic cranes to the loading device, to push the billets on the furnace approach roll table. It is designed to receive billets from the loading device and deliver them to the furnaces. The furnace charging pusher pushes the billets after evolving from the approach roll table into the furnace and moves the entire charge inside the furnace, and thus pushing the heated billets onto the delivery roll table at the discharge side of the furnace. 9. Reheating furnace and its process. In merchant mill there is a continuous pusher type reheating furnaces, gas fire burners, 3-zone furnaces, soaking zone, heating zone, preheating zone, capacity 60 ton/HRS. Heated billets supply for rolling. In reheating furnace, the cold billets are loaded in loading device B overhead crane, OHC, from billets yard as per quality requirement of mill. By delivery roll table, the billets has been sending into charging side of the furnace. After this, the billets are charged by use of charging device, through pulpit operation manually, electrical and mechanical device. In standard manner 1, the charged billets are heated and soaked in furnace at 1200 plus or minus 50 C. After this, heated billets are pushed by charging pusher mechanism, then discharged heated billets on delivery roll table. These heated billets are passed between rollers, mechanical stand, and by hot rolling process it gives finished merchant products. 2. Research methodology. A problem identified. The merchant mill of steel plant produces finished products as per customers and market requirement, but sometimes produces unfinished product, cobbles, due to unexpected problem in hot rolling process. These problem arises due to failure of lubrication system in rolling stands, cooling system in stands, electric failure, uneven temperature of billets, mechanical problem, and high rolling speed, etc. This problem impact production qualitatively as well as quantitatively, loss of human effort, raw material wastage, and cause breakdown of mill. Furthermore, it takes a lot of time to start rolling again and hence cause high production loss. B. Statement of problem. The mill was undergoing loss of production due to variations in hot rolling process parameters. Following problems were identified. Variability in quality standards of finished products in same profile. Change in operational parameter during rolling process of mill. Increasing the cobbles in rolling stands, it gives unfinished product. Roll breakage due to uneven rate of rolling and lack of maintenance. Generation of excess load in rolling stand during operation. High-speed rolling gives different types of breakdowns. Uneven temperature of heated billets supply from furnace. See research objective. To analyze the relationship between the temperature and load of billets at stand. To analyze the relationship between the heating zone temperature and load on motor of stand. To develop a model under the production of bar and angle. D. Research framework. The data are collected for TMT 25 mm bar and angle 50 mm production. Under these conditions, the billet temperature at second stand during passes between roller, heating zone temperature and load on stand 2 motor are measured with the help of control devices. These data are analyzed in order to determine the relationship between them. 3. Data collection and analysis. The primary data is collected directly from the fixed-type radiation pyrometer installed near stand 2 of the reheating furnace and mill operation. The variables measured in the process of data collection are as follows. Temperature of billet at stand 2 in 0C equals Ts. Temperature of heating zone in 0C equals Th. Load of roller in ampere equals L. Where load of roller, L, is dependent on other two variables, i.e. temperature of billet in stand 2, Ts, and temperature of heating zone, Th. Hence, load of roller, L, is considered as dependent variable and other two are independent variables. Heating zone temperature, Th, the temperature of reheating furnace in which the billets are heated at desired rolling temperature, hot rolling process. Temperature of billet at stand 2, Ts, it is the measured temperature of billets at the point when the billets are passing from stand 2. Load of roller, L, the usage of current to drive the motor of stand 2 which is used to rotate the roller and to transfer the billets for further process. It is measured in ampere. These variables are measured for the merchant products of TMT 25 mm and no of observation taken under each condition is N equals 30. A. Data analysis. The tool used for the analysis of data collected at different conditions is IBM SPSS Statistics 2.0. The tool is used to analyze the following. To determine the descriptive analysis of the readings. To determine correlation between all the variables. To perform multiple regression analysis. This is used to formulate formula under these two conditions. I. Analysis of TMT 25 mm bar. With the help of correlation, we can determine how strong the relationship exists between these variables. As we can observe from the table, there is a weak negative linear relationship between load of rollers, L, and billet temperature at stand 2, Ts, i.e. -0.261. There is a moderate negative linear relationship between load of rollers, L, and temperature of heating zone, Th, i.e. -0.442. Bell-shaped curve in histogram fulfills the assumption of multiple regressions, that is, normality of the error term distribution. According to regression coefficient table, we can formulate the formula for the relationship between load of rollers, L, in term of temperature of billet at stand 2, Ts, and temperature of heating zone, Th. Load of roller, L, equals A plus B1 x1 plus B2 x2. L equals 1879.938 minus 0.171 times Ts minus 0.657 times Th. Where 1879.938 is constant called intercept and is denoted by A. 2. Analysis of angle. With the help of correlation, we can determine how strong the relationship exists between these variables. As we can observe from the table, there is a weak negative linear relationship between load of rollers, L, and billet temperature at stand 2, Ts, i.e. minus 0.291. There is a moderate negative linear relationship between load of rollers, L, and temperature of heating zone, Th, i.e. minus 0.302. According to regression coefficient table, we can formulate the formula for the relationship between load of rollers, L, in term of temperature of billet at stand 2, Ts, and temperature of heating zone, Th. Load of roller, L, equals A plus B1 x1 plus B2 x2. L equals 1393.291 0.253 times Ts 0.327 times Th. Where 1393.291 is constant called intercept and is denoted by A. B. Production analysis. We have collected the data of amount of monthly production of merchant mill and respective unfinished products, before and after the installation of radiation pyrometer, i.e. on November 2018. These are as follows. I. Data collection and analysis before installation of radiation pyrometer. Data analysis. We found that the generation of unfinished product in 8 months, from April 2018 to November 2018, is 1,752.64 ton, which is on average 219.08 ton/month. Percentage of cobble, unfinished products, generation was 0.44% of total finished products. Total production in 8 months was 395,061 tons/month, i.e. 0.395 mt. Other reasons are not included here, which impact production. Hence there was a loss incurred. Approximate mean production loss, before installation, equals 219.08 tons/month. 2. Data collection and analysis after installation of radiation pyrometer. Data analysis after installation impact radiation pyrometer. A digital fixed-type radiation pyrometer was installed on November 27, 2018 near Stand 2, Merchant Mill. BSP data was collected from the product logbook of mill and monthly report of production. We found that the generation of unfinished product in 8 months, from December 2018 to July 2019, is 858.71 ton, which is on average 107.33 tons/month. Percentage of cobble, unfinished products, generation was 0.215% of total finished products. This data shows the decrease in cobble generation. 3. Graphical analysis. 4. Result and discussions. Analysis of the collected data after installation of fixed-type digital radiation pyrometer model. No. Impact EBA 5 signifies the load is inversely proportional to the temperature. This gives the new formula for calculating the generated load on rollers of stand. Also, continuous monitoring the temperature of heated billets shows the minimum safe rolling temperature and safe load limit, which must be set and maintained for continuous rolling. Benefits of analysis after installation of radiation pyrometer. Continuous monitoring the temperature of heated billets. Increased the productivity 111.75 tons/month and decreasing the production of unfinished product. Increased production per year is 1,341 tons/year. V. Conclusion. The generation of unfinished products along with the finished products gives loss of productivity. It was due to excess load generation in motor to operate rollers in rolling stand because of less temperature of heated billets in furnace. This problem solved by installation of radiation pyrometer, hence continuous and uniform observation became possible. After this installation, increased productivity is observed, approximately 111 tons/month, and subsequent decrease in cobbles. Also, financial impact on the company is around 5.7 crore Rs/year by increased production. Also, our analysis with the help of tool IBM SPSS Statistics 2.0 of data load and temperature, made it possible to standardize the present system in the merchant mill. The tool determined the correlation and multiple regression analysis, hence derived standard formula for all the products in the mill. 6. Future scope. This instrument, radiation pyrometer, can be used as control process parameters for rolling in any steel industry. Formula derived in this study for the different profiles, angles, channels, and bars, can be used to maximize production in the rolling mill of steel plant. Acknowledgement. I am very thankful to express my gratitude towards to Mr. P.K. Nanda, Manager, Instrumentation Department, Sale Pila Steel Plant, for guiding me during this research work.